So once again, I'm Samantha, this is Kylie over here,
Hello.
and tonight we'll be presenting to you Jupiter plus the 4 Galilean moons that orbit around Jupiter: Io, Ganymede, Callisto, and Europa. So first is Jupiter. Jupiter is a gas giant that's been known since the ancient times, which basically means it's observable in the night sky with just the naked eye. So it's been documented, it's been observed for years, like since documentation goes back, we've known Jupiter existed. So, but it was first officially, I guess, observed by Galileo. He takes the credit, but we've known it for a long time. Jupiter is the biggest planet with a 43,441 mile radius and mile diameter. I confused myself there. And a little fun fact: Jupiter, if it was just a little bit bigger, actually, it could actually be a dwarf sun. It's not too far. It's not too far off. It has like the chemical composition. It just needs to be bigger. So we could have had two suns, but too bad Jupiter's too small. So Jupiter is 5.2 AUs from the sun. I don't think we explained what an AU is.
Yeah,
We did.
We did? Okay, good.
It was a distance, but how was it calculated?
It's the distance from the Earth to the Sun.
It's the average distance from the Earth to the Sun.
So
So instead of saying 93 million miles, we say 1 AU.
Okay,
So then the rest of these numbers are relative to the Earth,
so, but 1 AU equals 90.
93 million miles.
Mhm.
So Jupiter then is a little over 5 times farther from the Sun than Earth is.
And then, yes?
So what you're telling me is Jupiter also has the same problem like Pluto. It's just not big enough to be.
Yeah.
It's not big enough to be
Yeah, it's
the
not big
thing
enough
that
to
it's
be.
supposed to be.
Yeah. They're in the same category there. But 5.2 AUs from the sun is 4.2 AUs from the Earth slash 6.2. It depends on where the planets are in their orbit, so it varies. So, Jupiter orbits at 29,236 miles per hour, which is really fast to us, but it's actually really slow compared to like other orbits and other things in space and stuff. So fast yet slow. So that all in all means that one Jupiter year equals 12 Earth years.
So you'd be a little over a year if you were 17.
Yeah. So, and a little fun fact about Jupiter, it doesn't rotate as a solid sphere because it's a gas giant. And because it's a giant in general. So, its days vary from 9 hours and 56 minutes to 9 hours and 50 minutes. 9 hours and 56 minutes is around the northern and southern hemispheres, while 50 minutes is like central. So, it also clocks in at the fastest like rotation speed. Its days are really short on Jupiter, so you have a lot of days in one Jupiter year. Beep. All right. So do you like incredibly varying temperature degrees and like weather and stuff? Then Jupiter is just perfect for you. Cause let me tell you, on the surface it has a negative 234 degrees average temperature. But once you start getting down into that core, it can get up to 43,000 degrees Fahrenheit. So it gets really hot really, really fast.
Talk about messing with the thermostat.
Yeah. Someone in there's just messing with Jupiter's thermostat, man. So, no, I'll go on that later. So, Jupiter also has a lot of gravity. It is about 2.52. I got this math wrong in here. Ignore that. Ignore those numbers. I never fix that. But it is about 2.52 times that of Earth. So if you were 100 pounds on Earth, it's like it's rounded up. But if you're 100 pounds on Earth, you're going to be 252 pounds on Jupiter, essentially. So once again, if you want to get crushed by gravity, Jupiter is perfect because just being in the atmosphere, you're going to get crushed by gravity. Yeah. So, well, that is, if you're going to probably be in the atmosphere of Jupiter because we don't really know if there's a surface on Jupiter. Hypothetically, we think that there might be some sort of surface, but we can't confirm yet because it's easier said than done just shooting a satellite into Jupiter and documenting if it has a surface or not. So, yeah, and there's a nice little, that dummy behind me freaked me out. And there's a nice little picture of Jupiter and some of its moons.
His name is Jerry.
Actually,
Yeah.
Like Jerry.
Yeah.
And a nice little tidbit about Jupiter, it has what we call the big red spot, or the big red storm, whatever you want to call it. If you don't know about it, then I don't know what to say. It's like the pinnacle thing about Jupiter. So it is like a hurricane tornado sort of storm thing. It has a lot of winds. And it has been storming for the past 350 years. It is a storm, so it's been storming for the past 350 years. And that size right there that you see could easily fit 3 Earths in it, like 3 to 4 Earths about. So if we were to chuck Earth in there, we'd be decimated. One, for a lot of reasons, but also because he just chucked us into, like, the big storm. But a little fun fact about the big red storm is that it's actually slowly shrinking every week. Every week it, like, peels off another layer of flakes and stuff. So every week it is shrinking, and it's estimated that in just a couple of years, couple of decades, I think, it's going to be completely dissipated and gone. And there's going to be no more big red storm, which is sad. Jupiter won't have anything anymore.
Cheers.
Very. So, here is just a couple of pictures of the big red storm. That's infrared, and that is the red spot compared, like, estimated about what it was in 1890. And this is what it is just a couple of years ago, so it is definitely shrinking. It's fact, you can't argue it, it's shrinking. And that's just a fun little gif I found of, like, if Jupiter was, like, the distance away from us that the moon is. So, if
250,000 miles.
Yep. If we had Jupiter as the moon, that would happen.
sort of scary.
Very. And then another little fun fact about Jupiter, its gravity is so immense that I'm going to go on this point first because I know you're going to go on the other point later. But one, its gravity is so immense that as it orbits, it actually brings in a lot of asteroids and, like, controls a lot of comets and stuff. And the reason why I want to bring that up is because of Jupiter, if Jupiter weren't there, we probably wouldn't exist today. Because if Jupiter hadn't pulled in so many asteroids and, like, took the damage and took it into its own gravitational pull, who knows how many asteroids would be headed for Earth and stuff. So Jupiter, in a lot of ways, is like our big brother just protecting us. And then another little fun fact is Jupiter's gravity, once again, is so immense that it's just casually carrying along these 2 ginormous asteroid belts in its orbit. So it's just casually, it's like no biggie air to us. But yeah, do you want to go on
You
that?
want me to talk about that right now?
If you want to, go for it.
It's really
So,
interesting.
it is, this is really fascinating. So, these are called the Trojan asteroids. And they actually exist in what's known as Lagrange points. So anytime you have 2 massive bodies that have some amount of space between them, they're gonna exert a gravitational pull. And there are specific regions where that gravity is kind of localized, which is really crazy, but they're called Lagrange points. There are 5 of them. So you can see obviously 1 and 2 here. Oh, I don't want to touch the screen, I suppose. There's also a Lagrange point. How am I going to do this? There's a Lagrange point between the planets, or between the big massive objects, but we've got other objects in there like Mars, and so nothing is really evident in here. There's also a Lagrange point out here. So the Jupiter and the Sun actually have a gravitational influence on this side of the Sun from Jupiter, and then on the opposite side of the Sun from Jupiter. So there are 5 Lagrange points where gravitationally they could be holding objects. The only 2 of those Lagrange points that are apparent with Jupiter and the Sun, though, are these, and I don't remember which. We'll just call them Lagrange 1 and Lagrange 2.
What is the green orbital?
That is Comet.
Okay.
Comet, yeah.
Yeah,
Yeah.
that just happens to be in this.
Not sure which one though, it's just a comet.
Yeah, it's
It's there.
2015. It was something that was discovered in 2015. I'm not sure. But yeah, so we have those. They're called the Trojan asteroids, and they gravitationally they just hold fairly steady ahead of and behind Jupiter. Very little known fact, but very fascinating.
Go right ahead.
Next is the Galilean moons, which is Io, Europa, Ganymede, and Comus.
So I'm going to be doing Ganymede first. Ganymede is one of the Galilean moons discovered by Galileo, hence the name Galilean moons. In January of 1610, there was three other moons discovered along with Ganymede. Galilean moons, once again. I'm just going to call them the siblings because I like the idea that they're siblings, because I like putting humanoid stuff on space objects. But anyway, so Ganymede has a diameter of 3,723 miles, which definitely puts it in as one of the biggest objects in our solar system. It's actually bigger than Mercury is. Not as massive, it actually has less mass than Mercury, but it is bigger than it for sure. And obviously it's going to be the biggest moon too, and biggest Galilean moon. So its surface is mostly composed of rocks and ice, along with a liquid metallic core, which we'll be getting to in just a moment. That's going to play a part. And it has a gravitational force of 0.14 g-force, or grams per square inch. I think I got it. Which is pretty comparable to Earth's moon. That's pretty similar. I think that it has just a little bit less than our Earth's moon. And it has the second slowest orbit of the Galilean moons, one orbit for every 4 orbits of Io, which Io is the fastest one, so it's just zooming past. So. And here, where is he? Here's Ganymede, compared to its other siblings, Europa, and compared to Earth and Mars and all that. So Ganymede is believed to have formed along with Jupiter, so we don't really have a specific date when it formed. It was formed from leftover Jupiter dust and all of that. And fun little fact, it has a magnetosphere in it, which is pretty unique to moons because usually they don't have a magnetosphere or anything. Hello. And if you're wondering what a magnetosphere might be, essentially, our Earth has this too, and it's like a magnetic field around any planet or a moon, if it does have it, that can protect it from solar rays. I don't quite know how it works, so I can't explain that part, but just know.
That's where that liquid metal core comes in.
Yeah, it causes a magnetic field to start forming because of the friction in the metallic core, I believe, something like that. So then it protects it from solar rays and stuff, and it's one of the essential reasons why we have life here on Earth. Because if we had solar rays and like flares just coming at us every 10 months, we wouldn't be living for long. But and fun little tidbit also about it is it has a region in the northern part, right here actually, called the Galileo region, and it is just a region of a bunch of craters and canyons and cracks in it. And it's just really dark compared to the rest of it, as you can see. And I guess you could count this part of it too. And it is likely created in a period of geologic activities. So it's interesting to think that this was geologically active at one point. I don't think it still is, but just once. And it might have an atmosphere, maybe, we don't really know. Because in 1972, some astronomers observed that, hey, it does have an atmosphere, like a very thin atmosphere. So we believed it for a time, and then Voyager, I think 1 passed by it, and observers like, no, that's not an atmosphere on there. You guys are just bluffing. There's no atmosphere on Ganymede. But now Hubble is looking at Ganymede and looking at it very precisely, and it's like, I don't know, guys. I think there is an atmosphere on it. It's just like a very, very thin atmosphere. So we really don't know. It's very thin if there is one. And ignore the fact that it's upside down. I could not change it. But there's Ganymede just going across Jupiter, and Voyager going past it.
Oh, yeah, fun.
So yeah. Beep. And next we'll be doing Europa, which is another one of the Galilean moons with the siblings. It was discovered along with its siblings in January 1610, and it has a radius of 1,939.7 miles, which makes it the smallest of the Galilean moons. So quite a drastic change going from the biggest to the smallest. But even still, it's the 6th largest object that we can observe in our solar system. So even with that, it's the smallest of the Galilean moons, but we can still observe it, and it's still pretty big. So that says something about the Galilean moons. They're pretty big, man. So it has a water ice crust with a potentially iron nickel core, which we will get to that in just a moment to explain some fun stuff about it. And the water ice crust does like function as tectonic plates, a little fun fact, which again we'll be getting to, but it has tectonic plates, which explains these little fissures going on in it. I'll explain that in a minute. There's a lot of things I'm going on to the next slide, so. It has a gravitational force of 0.13 g-force, or grams per square inch, which is less than Ganymede, so less than our moon, and it doesn't have a lot of gravity overall. And it is the second fastest of the Galilean moons, clocking in at 30,600 miles per hour and going pretty strong. And that is Europa compared to our own moon and the Earth, so they're pretty similar in size. Alright, so Europa once again was made along with Jupiter from leftover Jupiter material and all that, and it is incredibly smooth. It is the smoothest object, I believe, in our solar system. And we can see that from the picture that I put up previously. It's so smooth you can see the cracks and fissures in its tectonic plates. So, and because of that, it actually has a very young surface. A very smooth surface suggests a very young surface. So its surface is like regenerating like all the time, and that is actually because of a giant salt ocean that is under Europa. I forgot the name of it for a second. So fun fact, there's a giant salt ocean under it, which is huge. It is amazing. Not a lot of moons have water on it, but this one does, and it comes up in geysers, though we can't really observe it as well. It could possibly inhabit life, which is why it's so big. So, because obviously if there's water, there could be potential for life and all of that, because life needs water. So that is an incredibly huge, big thing, and the surface ice acts as tectonic plates because of the underwater action going on. Let me read. It's hard to explain this next part that I'm going into. But essentially, the tectonic plates are moving because of a heating source coming from inside of Europa. So that's how tectonic plates are moving, and when the tectonic plates are moving, the geysers come up and they spray their water, and when they spray their water, the salt water like cleanses the surface and like coats the surface in salt water, and that's why it's so unbelievably smooth. And fun fact, in 2020 there's actually a mission planned to go to Europa called the Clipper mission, and originally it's just planned like, oh yeah, we're gonna just like figure out like the saltwater ocean under it, but keep this between us, secretly they're also gonna look for life too. So that's not so secret, but it also like wasn't intentional, but they are gonna do it. So look forward to that, 2020 Clipper. Keep an eye out for that. Go right ahead. So here's some other pictures. Here's Europa's water mass, which is actually more than we have. Europa has more water than we do. So that can be pretty significant. And then obviously some other water masses and other moons and planets. There could be potentially Clipper in 2020. And here is a better picture with all the cracks and fissures on Europa. And essentially, it kind of looks like blood, but that's not what it is. Trust me, there's no genocide going on. What it is essentially is the weakness in the ice tectonic plates that like shows, especially when there's really huge tides. And Europa has big tides because there's Jupiter on one side of it, and then Ganymede and other moons on the other side of it. So there's tides like pulling it all the time, and then there's cracks, and it's cracks that you see here get bigger. They swell up more because of it. So that's what all those are. They're like cracks in the tectonic plates. So yeah.
Next up is Io, which was discovered January 8th in 1610, along with the other Galilean siblings. It has an iron core, liquid silicate, sulfur, and rocks on its surface, which is a lot of fun stuff. Its diameter is 2,263.8 miles around, which makes it the third largest Jupiter moon. It takes 42.5 Earth hours for one orbit around Jupiter, or 2.5 days, with an orbital speed of 38,787.9 miles per hour. It has a surface gravity of 1.796 mass per square inch. I believe, mass per square inch.
It's meters per second squared.
Meters per second squared, which is significantly smaller than Earth's 9.07 meters per second squared. And then right over there, that little blue geyser-looking thing is Io's largest volcano, which is aptly named Loki. And so it is one of the most volcanically active bodies in our solar system. Its volcano, Loki, again, is due to erupt any day now. So it can be observable through telescopes even, too. It has a rocky and treacherous terrain, but it is also the youngest surface in our solar system. And then every second, Jupiter takes about 1 ton of Io material. And then right over here, right down there, is Loki. And then there's some more pictures of Io and Loki. And next is Callisto, which was discovered January 7th, so the day before Io was discovered. It is an ice, rock, and possibly a salty ocean underneath. Its diameter is 2,995.4 miles, and that makes it the second largest Jupiter moon. It takes 17 Earth days for one orbit around Jupiter with a speed of 18,350.1 miles per hour. And then it has a gravitational force of 1.236 meters per second squared, which is also significantly less than Earth's, but also a little less than Io's. So it is the third largest moon in our solar system. It's almost about equal in size to Mercury. Before scientists knew about the craters, it was called the Ugly Duckling Moon. And it has a salty ocean about 155 miles beneath its surface that could hold life, kind of like Europa. It was named after a woman who turned into a bear because of Zeus shenanigans. And it has a very thin carbon dioxide atmosphere. And here's some Callisto pictures, and then Callisto along with Io, Europa, and Ganymede orbiting around Jupiter.
Io, this one's Io, this one's Europa, this is Ganymede, and this one's Callisto.